Let us do the questions from NCERT, Class 10 Chapter Circles, and here we are going to talk about Exercise 10.5. Here comes the first question. According to the question, in the given figure, A, B and C are 3 points on a circle with center O such that BOC is equal to 30 degrees and angle AOB is equal to 60 degrees. D is any point on the circle such that it lies on the circle other than the arc ABC. Find the angle ADC which is in red, right? Okay, now how do I do it? For this, you're given that angle BOC, the yellow angle, is equal to 30 degrees and angle AOB which is equal to 60 degrees, which is blue angle, right? Now you're supposed to find out angle ADC which is the red angle, right? Now angle AOC is equal to angle AOB plus BOC, right? AOB, this is the whole angle which is there in the O, it is equal to 90 degrees, right? And we have studied in the theorem that if you have got the angle subtended by the arc at the center is double the angle which is subtended at the circumference. So angle AOC is equal to 2 times of ADC, right? Okay, now here AOC is equal to how much? You all know that. It is equal to 90 degrees. So angle ADC will be equal to how much? And that is equal to 45. A simple question, right? Let us move on to the next question. And according to the second question, a chord of a circle is equal to the radius, right? And find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. You can see the diagram on your screen. You're given a chord BC and this BC is equal to the radius of the circle. That makes OBC as a equilateral triangle, right? Now, you all tell me what is given to you? You're given that BC, the chord, OB, the radius, and OC, the radius are all equal to each other, which makes triangle OBC a equilateral triangle. This is an equilateral triangle, so angle OBC, this angle is equal to 60 degrees, right? Okay, now this is the blue one which is shown in the figure, right? You're supposed to find out the angle BMC, the yellow one down here, and also the angle BOC, we know it is equal to 60 degrees, right? Now, we know that angle BOC is equal to twice the angle of BAC, right? This angle. The angle subtended by an arc at the center is double the angle which is subtended by it at the part of the circle, right? So which makes this angle BAC is half of angle BOC. So what is the measure of this angle BAC, which is equal to 30 degrees? Okay, now this yellow angle on the top, it is equal to 30 degrees, right? Okay, now let us move on to the whole of the figure. We now know that A, B and C, all the 4 points are lying on the circle, which make this quadrilateral a cyclic quadrilateral. What is a cyclic quadrilateral? A cyclic quadrilateral is a quadrilateral in which all the 4 points are lying on the circumference of the circle. Now, what is special about this cyclic quadrilateral? You know that if sum of the all angle is equal to 180 degrees, right? Okay, now, so we have got one of the angle here, it is equal to 30 degrees. That means angle BAC, this one, and angle BMC, that is this angle, both sum up to how much? It is equal to 180, right? So, what is the measure of this angle BMC, this one, right? Just subtract, put the values. How much is it? It is equal to 150 degrees. You got it easily, right? Okay, let us move on to the third question. And what is there in the third question? Let us read. In the given figure, angle PQR, the green angle, is equal to 100 degrees, where P, Q and R are points on the circle with center O, right? You are going to measure the angle OPR, the angle in the red one, right? How do I do it? We are given the angle PQR is equal to 100 degree, right? So how do I find out this angle? For that, we know that angle PQR, this angle PQR, this one, right? This angle is a reflex angle for the angle. If you take it this triangle PO and R, this angle POR is the reflex angle, right? Now, if you have got this angle as 100 degrees, the green one, so this will be the double of it, right? So, what should be the measure of this reflex angle PQR? We know it will be equal to 200 degrees, right? If this is 100, this has to be 200 degrees. Okay, now the yellow one, it is visible on the screen very clearly, bright yellow color, and the measure is equal to 200, okay, 200 degrees. Now, let us go to the triangle POR. The triangle which is inside here, I can show it by the means of a laser, right? So, here I want to measure this angle PQR here, the internal part, right? You know that the angle around a point that is equal to 360 degrees. The yellow angle is 200, so the remaining should be equal to how much? 360 minus 200, which is equal to 160 degrees, right? Okay, the blue one I've shown here, it just came running, and here this measure of this angle in the triangle POR, it is equal to 160 degrees, right? Now, look at the triangle POR very carefully. What can you see here? You see that it is an isosceles triangle because this PO and OR both are the radius of the same circle, right? Okay, now since it forms an isosceles triangle, so we know that if the angles opposite to the equal sides are considered, these two angles should be equal. So OPR, the red one, and the other one which is opposite to it here, the one which is shown by the pointer, both should be equal, right? Okay, now how do I measure it? We will apply the angle sum property of the triangle. What does it say? That if you measure the three angles of the triangle, it sums up to 180. I know one of the angle, that is POR. We just now calculated it as 160. Put the value. What do you get? That 2 times of angle OPR plus 160 is equal to 180. So, what is the measure of the angle OPR? It is equal to 2 times of OPR is equal to 180 minus 160, which is equal to 20 degrees. So, what is the measure of angle OPR? Just 10 degrees, right? So, you got the angle, the red one, it is equal to how much? It is 10 degree. Okay, now let us move on to the fourth question. In the fourth question, we are given the figure in which we have got angle ABC is equal to 69 degree, that is the yellow angle, and we are also given that the angle ACB, the red one, it is equal to 31 degree, right? You're supposed to find out the angle BDC, which is the blue one, BD and C, right? I want to measure that angles. What do? We have got another triangle, right? It is triangle BA and C. If I want to find out the measure of angle BDC, I know this angle BDC will be also equal to angle BAC. Why? Because it is formed on the same arc, that is BC. The angle formed on the same side by the same arc should be equal according to a theorem. The angle in the same segment are equal, right? So, both are shown in the blue color. Right, now you consider only and only triangle ABC, that is the angle yellow one, that is angle B, red one, angle C, and angle A, which is in blue color. If you apply the angle sum property, we know angle A plus angle B plus angle C is equal to how much? It is equal to 180 degrees, right dear? Okay, now if I put the values of angle B and angle C, which is equal to 69 degrees and 31 degrees respectively, I get the measure of angle A, it is equal to 80 degrees after calculations, right? Because we know that 180 minus angle B minus angle C, that is equal to 180 minus 69 plus 31, which comes out to be 100. 180 minus 100, that is equal to 80. Now, I have got this angle A as 80. But I know this angle A and angle B both are equal. So, this angle B is also equal to how much? Angle D is also equal to how much? It is also equal to 80 degrees, and we are done. Okay, hope you understood, right? This is very easy problem. Fifth question, what does it say? It says that in the given figure, A, B, C and D are 4 points on a circle. AC and BD, AC and BD intersect at a point E, and angle BEC is equal to 130, the blue one, and angle EC and D, that is equal to 20 degree, the yellow one. You are supposed to find out the angle BA and C, right? Now what is given? The blue angle 130, the yellow angle ECD, that is equal to 20 degrees. We are supposed to find out angle BAC. For that, I am going to consider the triangle CDE. C, D and E. We know by the exterior angle theorem, suppose I am going to consider this triangle, the blue angle actually is the exterior angle for the triangle, that is C, D and E. So if you sum up the red angle and the yellow angle together, that is angle CDE and angle DCE together, it gives you the measure of the angle CEB, right? Okay, so you know that CDE plus 20 is equal to 130 degrees. So what is the measure of angle CDE? The measure of angle CDE is equal to 110. So red angle will give you the measurement. It is equal to 110. Right? You are supposed to find out what? You are supposed to find out the angle BAC. Okay, what is this angle BAC? The angle BAC and the angle CD and E, which is also equal to CDB, both are formed on the same arc, that is BC. Right? So if you draw this chord BC, the angle subtended by the same segment will be equal. Right? So this angle BAC and CDE both are equal. So we know that if angle CDE is equal to 110, angle A also should be equal to how much? It also should be equal to 110. So we are done with it. Okay. Now let us go to the sixth question. In the sixth question, you can see that ABCD is a cyclic quadrilateral whose diagonal intersect at point E. Right? If angle DBC is equal to 70 degrees, angle BAC is equal to 30 degrees, find the angle BCD, and if AB is equal to BC, find angle EDC. What are you given? You are given the angle DBC, which is equal to 70 degrees, the light blue one, right? Okay, and angle BAC, which is given in the dark blue color, which is equal to 30 degrees. You are supposed to find out the angle ECD, E, C and D, right? Okay, now to find ECD, we'll take the chord CD, which is shaking right now, right? Okay, now angle CBD, that is this light blue color, and angle CAD here, this angle, right? Both are equal because they are forming on the same segment, right? So both are in the light blue color now. If you have got one angle is 70, the other angle is also equal to 70. So CAD is giving you the measure that is equal to 70 degrees. Okay, now let us find out triangle BAD. Where is BAD? B, A and D. So it is actually the sum of the light blue angle and the dark blue angle, right? That is angle BAC and the angle CA and D, right? Okay, one is 30, other is 70. Right? If you add up these two, 30 plus 70, which will give you how much? It is equal to 100 degrees, right? Okay, so we know now the measure of the whole angle A, which is equal to 100 degree. But you know that A, B, C, D is a cyclic quadrilateral. Now what do you know about the cyclic quadrilateral? We know that if you add up the angle A and see which are the opposite angles of a cyclic quadrilateral. They sum up to how much? They sum up to 180 degrees. Right. So, you know one of the measure of the angle is equal to 100. So, the other angle, that is B, C and D, that is this angle, should be equal to 180 minus 100, which is equal to 80 degrees, right? So, it is shown by the red angle, right? Okay, so the measure of the angle BCD is equal to 80 degrees, right? Now, let us move on to the second part of the question, which says that AB is equal to BC. You are supposed to find out the angle ECD. AB is equal to BC. Where is AB? Here. AB and BC, this is BC. Okay, now these two are equal. So, I should consider which triangle now? I should consider the triangle A, B and C. You are supposed to find out which angle ECD. Where is ECD? E, this is C and this is D, right? Okay, now it has come in the pointers. Now, how do I do it? In triangle ABC, which is shaking now, I know AB is equal to AC. So, if you know that in isosceles triangle, I know the opposite angles are equal. So, if this angle is 30, so this angle is also equal to how much? This angle is also equal to 30 degrees, right? So, if angle CAB is to found, that is we know it as 30 degrees, the remaining BCA is also equal to how much? 30 degrees, right? But what is the measure of B, C and D, this whole red angle? It is equal to 80. A part of it is equal to, I know this part, right? And this part is equal to how much? It is equal to 30 degrees. So, what should be the remaining part? The remaining part should be equal to how much? 80 minus 30, which is equal to 50 degrees, right? So, just subtract it and get angle ACD. It is equal to 50 degrees, but you are supposed to find out angle ECD. Measure of ACD and ECD is the same, right? Okay, so that is also equal to 50 degrees. So, let us move on to the 7th question. In the 7th question, it says that the diagonals of a cyclic quadrilaterals are the diameters of the circle through the vertices of the quadrilateral. Prove that it is a rectangle. You can see that there is a circle and there is a cyclic quadrilateral, right? So, we have shown the circle which is not required. Anyway, we have given that it is a cyclic quadrilateral and the diameters of the circle are the diagonals of the quadrilateral also. You are supposed to prove that this quadrilateral ABCD is a rectangle, right? So, what is given to you here? ABCD is a cyclic quadrilateral having diagonals BD and AC intersecting each other at which point? That is O. Okay. Now, we are supposed to prove that A, B, C, D, this quadrilateral is a rectangle, right? So, for this, we will write the statement and prove. We know angle BAD is equal to half of angle BOD. Diameter is the diagonal. And in a circle, we know that the angle subtended at the center is equal to half of the angle which is subtended at the circumference, right? So, we know that angle BAD, right, B, A and D, it is equal to half of angle BOD and that is half of 180, which is equal to how much? This is equal to 90, right? So, I have shown that the angle A is equal to 90 degrees, right? Okay, now let us go and find out the measure of angle BCD. We know that the quadrilateral is a cyclic quadrilateral and in a cyclic quadrilateral we know that the opposite angle sums up to be 180. So, what is the measure of angle BCD? It is equal to, calculate it, you will get it as again 90 degrees, right? Okay. Now, again, if you find out the measure of other two angles in the similar way, you will get that all the four angles of the quadrilateral each is equal to 90 degrees, which makes this quadrilateral ABCD as a cyclic quadrilateral, which is a rectangle, and that is what we are supposed to prove. See, any quadrilateral whose four angles are equal to 90 degrees will be a rectangle, right? Okay, now let us move on to the 8th question. What does it say? That it says that if the non-parallel sides of a trapezium are equal, then we have to prove that it is a cyclic quadrilateral. You are given that it is a trapezium. The figure ABCD is a trapezium and you are supposed to prove that it is cyclic if you have got the sides which are non-parallel are equal to each other. Then it will be a cyclic quadrilateral. A cyclic quadrilateral is the one in which all the 4 points will lie on the circle, right? How do I prove it? For this, let us draw a construction. Draw this line AM perpendicular to DC and BN also perpendicular to DC. Right, what do I get here? Let us do the proof. Consider the triangle AMD, AMD and BNC. You know that AD is equal to BC, which is given to you, right? Okay, now we have constructed AM perpendicular to CD and BN also perpendicular to CD. So each of these two angles, that is angle AMD, this one, and BNC, this one, this both are 90 degrees by construction, right? Okay, now see, we are already given that the line AB and CD are parallel to each other. That is the parallel sides of the trapezium, right? But if two lines are parallel and if you draw perpendicular to them, they should be equal, right? So BAN and BM are equal. So that makes the two triangle AMD and BNC congruent to each other by Rhs Congruence Rule, right? Okay, that makes angle ADC, this angle, and the angle BCD, both the red angles, equal to each other by CPCT, the corresponding part of congruent triangles, right? Now, BAD, where is BAD? This B, A and D and ADC both are on the same side of the transversal, which is AD. AB and CD are parallel. So, what happens if you add up the angles between two parallel sides on the same side of the transversal? They sum up to how much? 180 degrees, right? Okay, now if instead of BADC, where is ADC? This one, ADC, I can always write it as BCD because they both are equal. We have already proved it, right? Now ADC के बदले BCD लिख दो, right? And then what do you get? Angle BAD plus angle BCD is equal to 180. This equation shows that the opposite angles are supplementary. That means the angle BAD, this angle and this red angle, both are supplementary, right? And we know that if the opposite angles of a quadrilateral are supplementary, the quadrilateral is a cyclic quadrilateral, hence proved, right? Okay, now let us move on to the 9th question. Let us move on to the 9th question. The 9th question looks complicated, but it is not at all complicated. Two circles intersect at 2 points, that is B and C, through B. Two line segments ABD and PBQ are drawn to intersect the circle at AD, PQ respectively. Show that angle ACP and QCD are equal, right? For this, you are given that two circles which is intersecting at point B and C. Here, see, this is B and this is C. Through B, two line segment ABD. This is the line ABD and PQB. We have got another line which is PBQ. Both are drawn to intersect the circle which is at A, then D, then P and it is Q, right? This P should be coming here. Let me write it here. This is the point P. You will not get confused. Okay, now you are supposed to prove that the angle ACP, A, C and P, this is the angle, and angle QCD, Q, C and D, that is this angle, both are equal to each other. How do we do it? For this, we'll make a small construction. We have to draw the chord AP. This is the chord AP and another chord that is equal to DQ. These two are the chords which we are going to draw, right? Now, what do we know? We will write it in the statement and proof form. So, for the chord AP, we have got the two angles on it on the same side of the triangle, the dark blue angles which are come up, that is angle PBA, this angle dark blue, and ACP, this dark blue angles, both are equal because they are subtended on the same chord AP, or you can say the same segment, that is AP. So they should be equal to each other. Now let us now talk about the next chord, that is chord DQ, right? The other one which we have made as the construction. You can see that in the chord, two green angles have come up. They both are equal because again the same reason, the angles subtended by the same chord are equal to each other, right? DQ is the chord, or you can say the arc DQ, right? Now why? Because they are the angle on the same side of the chord, that is angle DBQ. This is this green angle, and you have got the angle QCD. These two are again equal, right? Now look at the figure carefully. Can you find some vertically opposite angle which are equal? Yes, these two are again, this dark blue and this green angle, both are also vertically opposite angles, and you all know very well that the vertically opposite angles are equal, right? So since these two vertically opposite angles are equal, so that means that this blue and this green angle, that is the angle, the one which is given in the problem, that is from the equation 1, 2 and 3, we have got this angle ACP, that is this dark blue angle, and QCD, that is this green angle, should be equal to each other, and it is proved. Okay, now this exercise is over, and hope you all understood it very well. If you have not understood any of the problem, kindly revise it. And for any doubt, you have got the numbers. Kindly contact us on the number 93406362228 at Higher Classes Korba. Thanks for watching. All the best, bachcho.